Okay, so we'll be starting with this program, marine construction and welding. Here we'll actually look into primarily the constructional aspects of marine vehicles, right? The constructional aspects means, or that construction aspects will also include your structural arrangements, right, and their specifics with regard to the functionality of the particular object or the particular marine vehicle, and their so-called structural response against the service loads. So, we will try to look into all these aspects as far as the marine vehicles are concerned. By marine vehicles here we mean primarily the ships and the offshore structures, offshore platforms. We will keep ourselves limited to this. So, that will be one part, and the other part will be the fabrication aspect. By fabrication aspect, we will deal with whatever things that that come after the design is complete. After the design working details are done in the design office, then actually you will have to translate that idea to reality, means you will have to have the product. Till this time one can say that the things were in a so-called virtual mode. That means they have been drawn, it is only on paper or maybe in electronic mode. But for the actual purpose, you need the actual product. That means which will give you the service, say transportation of wheat. You need a particular kind of vessel, or transportation of trucks, automobiles. You need a different kind of, probably a carrier, right? So, there once the designs are done, that means your so-called preliminary design, detailed design, everything has been done, then it goes to the shop floor. Shop floor we will see in sequence what are the kind of activities involved, and the shop floor we are talking about here is essentially the shop floor of a shipyard. A shipyard is a term where, though the name is shipyard, does not mean that it only builds ships. It builds anything which is in water, more or less. That means the offshore platform also is built in a shipyard. The submarine is also built in a shipyard. One may name it as a offshore yard, submarine yard, but the general name is shipyard. That is a conventional anyway. Okay. So, that is what we will do, and in that constructional aspect, whilst looking in the sequences, we will keep little more extra emphasis on the joining aspect, that is the welding, because as I said, once the design is done, once the plates or the materials have been well acquired, cut to the required sizes and shapes, then you have to put them together, right? You have to put them together to get the entire final product, a particular ship or a particular submarine or offshore platform, whatever it is, right. So, that joining technique used is essentially welding. We no more do riveting these days, we no more do any, no bolting as such. Long back it used to be riveted ships, the joining used to be by rivets. Now welding has advanced enough, so we do welding. And there again different kinds of welding techniques are used for different requirements. So, we will look into those aspects, and finally, we will see once the welding has been done, you will have to be assured of the weldment quality. That means the joint you have made, whether it is it will serve you the required purpose. The required purpose means when welding is what? That means two pieces you are putting it together to make one integral piece. So, that integrity, how good is the integrity, that means how good is the welding done. So, some quality test, right. So, we look into the what kind of tests are done, right. All these we will talk keeping in our focus on shipbuilding industry, because there are various other methods of welding, there can be various other methods of weld testing, but we will only talk about those which are rather relevant to the shipbuilding industry. Okay. So, that is how the entire course will be. Well, so today to start with, I thought it will be worthwhile to look into the sort of the products which we will be dealing with, classification of that. So, classification of that means it is essentially types of ships and types of offshore structures, right. As far as types of ships are concerned, we have very broadly one can classify in two types. One is the merchant ships, another is your so-called defense crafts, the naval ships, right. The purpose of these two are definitely very different. Merchant ships are primarily for purpose of transportation of cargo, right, and the defense naval ships are for, well, defense applications, right. From the so-called design and construction point of view, there is no difference whatsoever between these two types, merchant or naval ships, because both are made of, well, steel or aluminum or any other construction material, both are to be welded, and both should serve the same, I mean similar safety requirements should satisfy, and so on and so forth, but the functional aspects could be different, right. So, in any case, we will not go in details of any of those naval vessels. There are different kinds of naval vessels. We will only talk about the merchant vessels. There is another kind of vessels also apart from these two, that is the merchant vessels. To have them efficiently functioning, you need some kind of support vessels. So, we will talk about what are those support vessels. And there is again another classification can be made, broad classification once again, that is sea-going vessels, inland vessels. That also can be, I mean within the gambit of your merchant vessels, there can be sea-going ones, there can be inland ones, right. Well, the inland, within the inland ones, again you have small cargo carrier, passenger carrier, right, and again there can be another division which is for, well, one may say from the pleasure tourism point of view, pleasure crafts necessary for tourism purposes, that is another class. On top of that, again there can be another classification of high performance craft, something called high performance craft or high speed craft, right. So, broadly I think so we can go like this. If we just look into the merchant vessels, I am just giving the name merchant vessels for all kinds of vessels apart from the defense ones, naval ones. So, in this there will be sea going, there will be inland, right, there will be support vessels, there can be what is referred to as high performance vessels. So, within this, I mean, this we are basically talking to make you aware that what all kinds of vessels are there. Obviously, in the entire course, we will not be taking each one of them and talking about them. Definitely, that is not feasible. But obviously, the basic principles of design, the basic principles of construction, the basic principles of welding all remains essentially same, right? But obviously, once you will become a naval architect, it's expected that at least you will have awareness of all these kinds of, I mean, whatever types of the vessels are there, right? So now, that's how we see that we could divide these merchant vessels in these 4 categories. Of the seagoing, we will have further subdivision. There can be many types of seagoing vessels, but we will concentrate primarily on these ones. The first and foremost can be referred to as general cargo carrier. General cargo carrier, a particular type of ship, as the name suggests, it carries general cargo of any nature, any type, right? Then another one is referred to as bulk carrier. That is essentially cargo in bulk, right? Say for example, you are carrying wheat, say 40,000 tons of wheat you will have to import from Australia, right? So, what could be the means of this transport of this wheat? It can be either pack them in bags, right? Those gunny bags or whatever, pack them in bags, load it in a ship and bring it. If it is done that way, then possibly it will be brought in a general cargo carrier. But if you do it, if you have a ship wherein you have big holds, like this room, say for example, even bigger, much bigger than this, wherein you just put the wheat in loose condition, right, and bring it, that is bulk carrier. That means you carry the cargo in bulk. Obviously, the second option is much easier or much more efficient than the first option, because unnecessarily otherwise you will have to use so many carry bags, wherein you have to first load it, stitch it and take it. So, not only it is the additional work involved in loading each bag, stitching the bags, it also adds to the weight, a fractional weight of those bags itself. Instead, you carry the whole thing in loose. But if I put the wheat in a general cargo hold, then again may not be very convenient to carry, because that is not designed that way, right? Functionally, it is not designed. So, the bulk carrier came into being because of this bulk trade, right? So, this bulk trade is going to exist. As long as mankind exists in this world, this bulk trade will exist, right? So, that is how these types of vessels they developed over the years depending on the requirement. That is what is a bulk carrier. We will look into this in little more detail later. And when you talk about say bulk carrier, it automatically implies it is a dry bulk carrier, right? Next comes, possibly we can mention the oil tanker. This is also a bulk carrier, but it is a liquid bulk carrier. So, we give a different name, oil tanker. There we carry oil primarily. By oil tanker we mean the crude oil tanker, crude carrier, because there is a huge trade of crude, petroleum crude transportation, right? Obviously, there are also vessels which carry the refined oil also, that means the petroleum product, right? We are not going in that. Broadly, we will talk about the oil tanker, which is a crude carrier, right? Then comes, well, container ship. container ship, what is it? As you can see the name, it carries containers. What are those containers? You may have seen on road or on rail those huge rectangular cubicle boxes, huge ones. So, instead of carrying the cargo in general form, in loose form, in general cargo carrier, you can carry anything, right? But anything means, suppose the furniture of this room is to be transported, and if I lift each chair individually and put it in a ship hold, right? That is the way a general cargo carrier is loaded. That means each unit cargo is individually handled. So, imagine if I have to suppose transport these chairs and I transport one by one, the amount of time it takes for loading and unloading. Whereas, if I have a box wherein I pack all the chairs and I just transport the box, it becomes much faster. So, that gives, that particular aspect, gave rise to this concept of containerization or container ships, because everything is eventually driven by economics. That is the bottom line, right? So, what people found that a general cargo carrier, the loading time and the unloading time, that may extend to the tune of 2 to 4 weeks, right? That means it calls on a port. First it unloads whatever product it brings, and then it loads. The entire process may continue for say 4 weeks. That means what? That 4 weeks is total wastage as far as the ship owner is concerned. He is not earning any money, rather he is paying, because the 4 weeks he is staying in the port, he will have to pay the port dues, right? Instead, if he could have cut it down to say 4 days of stay in the port, then what happens? He pays less. Not only that, he makes more number of trips. When the ship runs in the sea, when it cruises, then only the owner actually earns. He is spending when the ship is sailing, definitely, because the fuel cost, the salary, etc. But there is the earning phase, because he is taking somebody's cargo and he will be paying. So, he would like to make more number of trips. So, how to make more number of trips? One way would be increase the speed. Another way would be decrease the downtimes. Downtime means the ship is stationary, not sailing, and increasing speed could be an option, but that comes at a cost, very high cost. That you will later learn in your other courses, that the speed of the ship and the power required to deliver that speed, it increases exponentially, right? From say 15 knots to 16 knots, it is not a linear sort of increment in the power requirement, it is exponential, right? So, there is a limitation, you cannot go on increasing the speed, because power requirement increases means your fuel consumption increases, your cost increases, and that also you cannot go on infinitely increasing, because there is a cutoff somewhere beyond which you put more power, the ship weight increases, it does not deliver the speed, because speed is also related to the weight of the bulk, the ship. So, that is not an option, good option to increase number of round trips. So, one of the best option is to cut down in the port time. That can be done if I can cut down on the handling time, cargo handling time, that means loading, unloading time. So, that gave birth to the concept of containerization. So, what happens here? The containers are loaded on board the ship. Containers themselves come loaded from the consignee. Whoever is suppose sending some product, some machine equipment or whatever. So, containers he will take it to his factory premises, load the containers, and the containers are delivered to the port, and containers are put into the holds. Same thing on the destination port. Containers are taken out, put on a trailer and goes to the port of, straightway goes to the customer for whom the cargo has been assigned, right. And so what happens in the process, since the containers are of identical size, standardized size, so you can have the entire process of loading and unloading mechanized. So it becomes very fast. So that's how the concept of container ships came, right. But well, as you can see, as we are coming from general cargo, bulk carrier, oil tanker, container ships, basic purpose is same, transportation of cargo, but the functional requirement is changing because you are transporting different kinds of cargo. So that way, that has a bearing on the design of the vessel, that we will see later how the design changes. Well, then another very popular or important trade is import export of automobiles, right. So that gave rise to a particular type of vessel which is referred to as Roro vessels or Roro ships, right. Because suppose there is a, I mean, well, as you know, in the so called global trade, automobile is one of the commodity which is very heavily sort of imported and exported, right. Various, I mean, for example, this one of the biggest consumer of automobiles is USA. So they themselves are manufacturing many cars, many automobiles, but they also import many from the Europe as well as from Japan. So there is a huge trade in this. Now, how do you transport these automobiles? Again, you can put them in a container, but not all kinds of automobile may fit in a container. So putting in a container ship may not be very viable. Of course, the bulk carrier doesn't arise, question of keeping the containers, the automobiles. By this automobile, I mean it can be trucks, it can be passenger cars, right, which are self-propelled by themselves. In a general cargo carrier, again, it will not be very convenient, because here what we will have to see in Roro vessels or a automobile carrier is that how easily, again the same question, how easily you can load the cargo and how easily you can discharge the cargo. And in between stage after loading and discharging is the safety of the cargo remains, obviously, right. So how to do that? Since the automobiles can roll off themselves, so that's why they are called roll on, roll off ships. That on and off I have deleted and I have said Roro ships in short. Actually, the Roro, that name was derived from roll on, roll off. That means the car rolls on the vessel, docks itself there, wherever it is assigned. When the vessel calls in the port of destination, it rolls out. So that is how your loading unloading becomes very easy, very convenient. But so in the process, what happens? That is the functional requirement of this vessel, that the cargo will roll on the vessel, will keep it stationary there during the entire voyage, and again unlock itself and roll out. So the functional requirement, based on that you will have to design accordingly. So immediately one thing comes to the mind, that this kind of vessel should be a multi-deck vessel. Several decks should be there, because in each deck there will be several cars, isn't it? In a bulk carrier, you do not need decks, because entire cargo is put in bulk. In oil tanker, you do not need decks. So the functional requirement automatically gives you a clue how the internal structural arrangement should be. That is how, right? And also you can see a bulk carrier or a oil tanker, the port through which you will put the cargo and the port through which you will take out the cargo, again will be different compared to a container ship, will be different compared to a oil tanker or a car automobile, this Roro ship, right. So, all these, that means the functionality, that is why I am saying externally it may look all identical, but because of the functional requirement, internal arrangement will be different. We will look into that, those structural arrangements. So, that is Roro vessel. Then possibly you can talk about the passenger ships or passenger carrier, or also referred to as passenger liner, passenger vessels, passenger ships, passenger liner, right. These passenger liners are, well, as you know, long back when this aviation industry didn't, well, it did not mature that much. Passenger transportation also used to be, I mean, you cross a continent, it used to be by ships, right. That means the cargo was passenger, right. Today, of course, these passenger liners, they no more as such serve that purpose, but again it is becoming gradually very popular in the tourism sector. That means for holidaying, for sort of leisure purpose, people, they go in these passenger liners for spending some good time. Well, these are also huge vessels, and obviously here the cargo is a very delicate cargo, passenger, human being, right. So, accordingly you have to provide facilities. In other cases, the cargoes are not that delicate yet. In oil tanker, some delicacy is there. You will have to have proper vent mechanism, so that it is a fire hazard. In Roro vessel, cargo is again delicate from other point of view, that, well, cannot afford any damage to any car while handling. There cannot be any single scratch in the body, isn't it? That way it is delicate, as well as they are rolling on and rolling off, means they are on their own engine power within a confined space. So, question of ventilation is very important, because the pollution, say a Roro vessel with capacity of 2000 vehicles. So, 2000 vehicle will come inside a very confined space. Each will have whatever fractional amount of CO emission, you can imagine the polluted environment in that. So, the driver of the last car, when he parks the car and goes out, he may get fainted, because it is already so much heavily polluted inside, right. So, all those aspects are there. And in passenger liner, well, it is the most delicate cargo. So, obviously, you will have to provide for him the best possible, I mean, comfort and all those other aspects, because here again you have to keep in mind the passenger liners are primarily being used for leisure purpose. So, comfort is of the highest order is needed, and obviously safety. Safety in other vessels are also needed, but here the safety requirements are still more stringent, because here many more human lives are concerned, right. So, that is passenger liner. And then, well, another, probably it will be worthwhile to mention, that is what is referred to as LNG, LPG carrier. LNG and LPG carrier. You have any idea what is this LNG? Liquid, what? Liquid natural gas, right? And similarly liquid petroleum gas. So, there is also some bit of trade, intercontinental trade bit in this particular product. Now, if you have to transfer liquid natural gas or petroleum gas, obviously none of the above mentioned vessels are suitable, right. What is the fundamental difference in this particular product compared to all other products above? That is the requirement. I am saying fundamental difference of the product. That is the requirement of product storage or product storage. What is the fundamental difference in the product? Liquid, it is not gaseous. There is another liquid also, oil tanker. So, could I have taken it in an oil tanker? Definitely not. So, what is the fundamental difference? fundamental difference is fundamentally this cargo is a very low density cargo. Even in the liquid form also it is low density. And second, the temperature of the cargo. Right? These are the two very fundamental aspects, the temperature of the cargo and its very low density. So, what is happening in the process? You know, in ships, there are some requirements of what is called load line requirement. Load line requirement means that you are not allowed to load a ship beyond a certain loading point, beyond a certain capacity. Beyond a certain capacity means what? Means you have designed the vessel and you have to sort of define the full loaded draft. That means when the ship is, say the ship, a particular ship is built, designed for carriage of 10,000 tons of cargo. That means in the departure condition, the maximum weight of a ship is when? At what point of time you have the maximum weight of, total weight of the ship. This weight of ship we refer to as what? Displacement. There is a term called displacement. We do not say the weight of a ship, we say displacement of a ship. Why this term has come, you know? Can you guess? It displaces the water, equal amount of water, right? Anyway, so that's how this term is used, displacement. So, can you tell me when a ship will have its maximum displacement? During departure, loaded departure. Yeah, there are, right, there are various stages, loaded departure, loaded arrival. These two are different, there will be difference in weight, because in loaded departure condition, you will have the entire fuel stock, you will have the entire freshwater stock, you will have the entire provision stock, everything is full. Loaded arrival, many of these things have depleted to a bare minimum level. Anyway, so this loaded departure condition, at that condition, the ship should be floating at a certain draft which is already predetermined. You may have empty spaces available in the ship, but you cannot load further cargo. Then what happens? The ship will sink beyond that line which has been prescribed. That is the load line, also referred to as plimsoll line. Plimsoll line also is referred to as. Why? Because there is, from the safety aspect, there is a requirement of what is called freeboard. You know, these are, of course, you will learn all this elsewhere also, but I am just maybe it's worthwhile to mention. This, what I am drawing is just a section at the mid length of a ship. Externally you can see like this. So, this is your, let us assume that this is my LWL, load water line at the loaded departure condition. So, this distance, the distance from the deck at side to the load water line, this is referred to as freeboard. This is referred to as freeboard, right? There is a specific requirement that the freeboard cannot be less than so much, right? There is something called SOLAS, you know. Safety of life at sea. There is a SOLAS convention. This particular convention, they outlines or gives the guidelines of various safety features, safety aspects which are mandatory, which you will have to follow while designing, while operating and all that, because human lives are at stake. So, this SOLAS convention prescribes freeboard, that for a particular type of vessel, this much has to be the minimum freeboard. You cannot have less than that. When it may become less, suppose I have loaded, I overload it. So, overloading is not only a problem of structural point of view, but it is a problem from the safety point of view. So, that is not permitted. Anyway, so what happens in case of higher density cargo, right? You load to a certain extent, I mean that way you design, and your vessel very easily attains the load water line or the, well, I mean it sinks to the required draft. But in case of LNG and LPG carrier, it hardly sinks to the sinks to any draft unless until you really load a huge amount of the cargo, because the density is very less, of the order of 0.5 or so, right. So, in the process of what happens, LPG, LNG carrier, like here I have drawn, only little bit is above the water, measured part of it is below water. In LNG carrier, it can be otherwise. Much above will remain, that means there is freeboard is no problem, there is other kind of problem coming into picture. The too much of exposed area above water level means too much of wind force will be working. So, that again gives another design problems, and then of course, the cryogenic temperature. Low temperature means it is literally a, I mean substantially sub-zero temperature, right. So, that cryogenic temperature means accordingly you will have to have all those thermal insulations and containment system. So, that is how, that is a class by itself, very sophisticated vessels, and it needs special attention obviously. So, broadly we can say the seagoing merchant vessels can be classified in these, probably we have done it in 6 different heads, right. Let us take a quick look at the other ones, the inland vessels. In the inland vessels we have, well, the river crafts, essentially the river crafts. What are they? The river launches, the launches for small time, I mean for ferrying of passengers across the river or along the river, right. Then you have through inland waters also we transport cargo. So, them we do not name them as cargo ships, but we name them as barges, barge. We call them as barge. So, these barges could be self-propelled or could be dumb barges. That means it can have its own propulsion mechanism. So, it becomes a self-propelled barge. That is a, one can say, miniature version of ocean going ships, a cargo ship, right. Or dumb barges. Dumb barges means it does not have any propulsion mechanism, it has only cargo holds where to load the cargo. So, then you will have to have another prime mover or a vessel which will push it or pull it through these dumb barges. So, those come under the support vessels. So, in inland primarily these two, launches and barges. Then we come to these support vessels. Which provide for helps in the proper operation of of the seagoing vessels, inland vessels, etc. They provide support, because we started with that merchant vessels, naval vessels. Naval vessels, okay, it is a very specific function. Merchant vessels primarily trade, primarily transportation of cargo. All the seagoing vessels what we have just now talked about, all are basically cargo transportation. Inland vessels also we have talked about is cargo, because launches passenger cargo, barges general cargo. Support vessels, they are not for any so called transportation, cargo transportation purpose, but for facilitating this process, right. So, first and foremost, support vessel could be referred to as tugs, tug, T-U-G, right. The function of these tugs are, well, for, like I said, if you have a dump barge, it can be one dump barge or there can be a couple of them put together, right. There can be various configuration of barges put together and one tug pushing it, right. So, we call it a pusher tug, right. So, that is how this is a kind of a support vessel, that means it moves that. Another support these tugs can provide is when a big ocean going vessel enters a port, you have to sort of berth the vessel, means parking of the vessel alongside the bank, which is called quay or the berth, right, because it has to be on the shore side such that your unloading, loading can be done easily. So, how to move that big vessel, say 100,000 tonner bulk carrier is coming. If it operates its own propeller, own propelling equipment and maneuvers itself to come to that position, it may not be able to do so. Means it, because you must realize that the braking mechanism is not as efficient as compared to the surface vehicles, right. So, with that inertia it goes and hits the quay, that will break, also the ship will be damaged. So, what is done generally, the vessels are maneuvered with help of tugs. So, the another support that tugs are they provide, apart from pushing the dump barges, they help maneuvering the vessels in the port area, right. So, a configuration like this, so what I have drawn is these are the tugs. This is a big vessel, in comparison the tug will be this small, right. So, two tugs pulling the vessel from the backside, another tug pulling it from the front, so that to keep the right course and slowly it takes to the desired destination wherever. So, that is the, so one can again, that is how have classification as river tug, which are essentially pusher tugs for barges. Then you can have harbor tug, what is the spelling of harbor? Harbor tug, that means the tugs, these tugs, their primary function is to maneuver big vessels within a harbor. There can be now ocean going tugs. What is this ocean going tugs? That means the first two tugs we have talked about, they will be operating in a sheltered water, right. River is also a sheltered water, harbor is also a sheltered water, but when you go in the ocean, it is not a sheltered condition, right. You will face the ocean conditions. So, there is a different class of tugs which are referred to as ocean going tugs. For some purpose, you need to pull a vessel right up to the ocean, or for rescue purpose also you may need, some breakdown has taken place, a tug goes out in the ocean and pulls it back. By this ocean, I do not mean really a mid ocean. A tug is not necessarily supposed to go to mid ocean. Mid ocean means 1000 miles away from the coast, not that way, but definitely in the ocean atmosphere it will be capable. So, that is ocean going tug, right. So, that is what is these tugs, and then you have along with firefighting tug. Well, by firefighting tug means all the above 3 tugs can be a firefighting tug, right? That means tugs along with having the facilities of firefighting. There is a fire in a vessel, the tug will go and douse the fire, right? So that is one of the support vessel. The other support vessels are, there is something called dredger, which dredges. The very name dredger means, for example, like always the harbor or the port is little inside from the sea, that is connected by means of a river or canal or channel. So you have to always maintain the required draft in those channels or the rivers, such that the designated vessels or the required capacity vessels can sail through that. Because as you know, there is always a sort of this phenomenon continues, that is siltation. Because of various other sort of factors, siltation of rivers takes place, siltation of canals takes place, right? Siltation is right, and because of this siltation, the draft availability or the navigability of the rivers or canals becomes poor. Means if you do not have the required draft, a vessel cannot move. So you have to clean that silt. Physically you have to take the silt up and throw it elsewhere. So that is being done by vessels called dredger, which dredges. The dredging operation is basically digging up the silt and removing it. So another support vessel is so called dredger. Then another support vessel is a pilot vessel. There is nothing but the pilot travels from the port to the ship, because when a ship enters the port area from the ocean, some designated point, pilot takes over from the captain of the ship. He guides the vessel to the port, because he knows this canal or the channel through which the vessel will sail and enter the port. Because as I said, dredging doesn't mean that the entire river geometry, say the river bed is something like this, right? Everywhere you do not have sufficient draft. A certain region probably you are maintaining navigable. You cannot go on dredging the entire width. So within the river or within the channel, a navigable canal is maintained, that the pilot knows very well. So he takes over. He guides the ship through that navigable canal. Why it is so important? You have any idea why it is so important? Because if you do not do that, the vessel may get, what happened? May get grounded. A term used, grounded, means stuck in the silt. Stuck means it will sit on the silt suddenly. Suppose there is the draft is less, it goes and plows in the silt. So what's the problem? It's not only the question of coming out, it may tilt and capsize immediately. Why? That we will learn later. Because the entire its floating condition has changed. It was stable when it was floating. A ship has to be stable, right? It is in a stable equilibrium condition. That means if some disturbance is given, some tilting force is given, it comes back to its original position. That is stable equilibrium. When the external force is removed, it will come back to its original upright condition. So that happens when it is in a floating condition. But the moment it touches the ground, then the floating condition changes. All those parameters changes. It becomes unstable and it may capsize. So that's very important. So that is what is a pilot vessel. The pilot travels. What's so important about it? because it's essentially ocean going vessel, because it will face the wrath of the ocean. The vessel is waiting out at the ocean, not in the sheltered water. So, this is one of the support vessels. And there are other types of support vessels, like which is referred to as supply vessel. Supply vessel, which is used in the to supply provision and other equipment to offshore platforms. Supply vessel, right? So, there can be some more other support vessels. We are not they are the general ones. High performance vessels. Which are they? They are essentially the planning craft, referred to as planning craft. Another one is referred to as hydrofoil craft. Right? There is something called SES, surface effect ship, surface effect ships. There is something called ACV, air cushion vehicles or hovercraft. So, these are some of the high performance craft. What is the difference? Why I have classified them as separate? Well, because they are high performance. What does it mean, high performance? It means no, speed is a relative term, right? In case of ships, speed is a relative term. We talk about speed length ratio, V by root over L, that comes from the Froude number, yeah, V by root GL, G being constants, V by root L. So, that is what is referred to as speed length ratio. Depending on the length for a given speed, it may fall in the high speed zone. It may be classified as a high speed vessel. So, here in high performance, the primary difference is that they are very weight sensitive vessels, that is number one, and their mode of operation is not by not only the buoyancy force which is acting, which is holding them in water. Rest all the vessels which we have seen, the sea-going vessels, the inland vessels, the support vessels, all are supported by buoyancy force only, right? They are floating, they are following that great Archimedes principle. But the high performance vessel, when they are performing, when they are cruising, part of the weight is supported by a lift force, something equivalent or something similar to that of aircraft. The aircraft does not float in water, it is supported by a lift force in air. It is not because of its buoyancy it floats, isn't it? Same thing in high performance vessels, this planning craft or hydrofoil or ACS or ACVs, all these, some kind of lift force, upward thrust is generated in the hull, thereby the weight of the vessel is fully or partly supported by the thrust, that lift force, and rest supported by buoyancy, right. So, that is how they are called high performance vessels. So, what is the great fun about it? What is the big deal in this? The big deal is the moment it gets supported by lift force means the entire thing is not supported by buoyancy. That means the vessel is much out of the water. Lesser part of the vessel is touching the water. That means lesser frictional resistance. The moment you have lesser frictional resistance, for the same power you have higher speed. Simple. That is how you attain a high speed. That is how the aircraft they fly at so high speeds, because the frictional resistance is very nominal. It is only the air resistance. That is how you will find this all these aircraft, they try to go up as possible, 30,000 feet, 38,000 feet. Why? The air is less denser, lighter. The more lighter it is, lesser resistance. So, it tries to pick up the highest altitude as fast as possible and then cruise, though it attains higher speed or lesser fuel consumption, right. Anyway, so that is what is the this high performance vessels. Of course, in detail you will learn in later courses. Another fundamental difference here, till this point, seagoing, inland and support vessels, all are so called displacement craft. They are referred to as displacement craft. Why? Because they are supported by buoyancy force. Okay. And so thereby we see that they are not generally weight sensitive. The weight is not a very important criteria. It is an important criteria, not very important, but in case of high performance vessels, they are very important, because if your weight becomes little extra, it will never come up. The lift force will not be able to push it out of the water, right. So thereby one will have to take care of the construction material of this. You cannot think of using steel or such heavy dense material for building of such craft. You will have to use a lighter material. Okay. So anyway, that is how we see that these are the primary classification of the merchant vessels or the ships. Okay. So we'll continue in the next class. Okay.